Protecting yourself when dealing with unpermitted electrical work involves several key steps. Firstly, documentation is crucial. Keep detailed records of all the work you performed initially, including a comprehensive list of materials used, precise dates of service, and any relevant discussions or emails exchanged. This documentation can serve as evidence of the scope of your involvement and the boundaries of your responsibility. Secondly, it's important to inform your friend, the homeowner, about the legal requirements surrounding electrical work, especially in the context of a kitchen remodeling project. Explain clearly that permits are typically required for such projects and that failure to obtain these permits can lead to significant legal consequences, including fines, project delays, and even the requirement to undo the unpermitted work. Thirdly, offer to assist your friend in navigating the permitting process. This could involve suggesting that you can help them obtain the necessary permits or recommending a qualified electrician who is familiar with local building codes and regulations to complete the remaining work. This demonstrates your willingness to help them rectify the situation and ensure compliance with safety standards. Fourthly, clarify your role explicitly. Make it unambiguously clear that you are not responsible for any unpermitted work they undertake. This statement should be documented in writing, if possible, to avoid any future misunderstandings or disputes. From a contractor's perspective, handling such a situation requires a different approach. 1. Confront the homeowner professionally. Address the issue of unpermitted work directly and explain the potential risks and consequences associated with it. These risks can include safety hazards, code violations, and difficulties selling the property in the future. 2. Offer alternative solutions to the homeowner. Discuss the possibility of obtaining a permit retroactively or hiring a qualified electrician to inspect and correct the unpermitted work. This demonstrates your commitment to finding a solution that ensures safety and compliance. 3. Establish clear boundaries. Inform the homeowner that you will not be involved in any work that does not comply with building codes and regulations. This protects your professional reputation and ensures that you are not held liable for any issues arising from the unpermitted work. 4. Meticulously document the conversation. Keep a record of all discussions and interactions you have with the homeowner regarding the unpermitted work. This documentation can be valuable if any legal or ethical issues arise later. 5. Protect your reputation vigilantly. Ensure that your name and company are not associated with any unpermitted work. This may involve removing your signage from the property or notifying your insurance company about the situation. 6. In extreme cases, consider reporting the unpermitted work to the appropriate authorities, such as the local building department. This is especially important if you believe that the work poses a significant safety hazard or violates building codes in a way that could endanger others. There are additional considerations to keep in mind as well. Ethical concerns are paramount. As a contractor, you have a fundamental responsibility to ensure the safety and quality of your work. Unpermitted work can compromise both, potentially leading to dangerous situations and code violations. Legal liability is another significant concern. If the homeowner experiences any issues related to the unpermitted work, they could potentially pursue legal action against you or your company, especially if they believe that your initial work contributed to the problem. Insurance coverage is also at risk. Unpermitted work may void your insurance coverage in the event of any claims related to the property. This could leave you financially vulnerable if any accidents or damages occur as a result of the unpermitted work. Finally, your professional reputation is on the line. Engaging in unpermitted work can damage your professional standing and make it more difficult to obtain permits or secure future projects. Building departments and potential clients may view you as unreliable or unethical, which can negatively impact your business. In summary, protecting yourself from the consequences of unpermitted electrical work requires careful documentation, clear communication, and a commitment to ethical and legal practices. By following these steps, you can minimize your risk and safeguard your professional reputation. Electrical work must adhere to the National Electrical Code, NEC, which is a comprehensive set of standards and guidelines for the safe installation of electrical wiring and equipment. The NEC is updated every 3 years to reflect advancements in technology and address emerging safety concerns. Adherence to the NEC is crucial for ensuring the safety of people and property, and it is often enforced by local building codes and regulations. One important aspect of electrical work is proper grounding. Grounding is the process of connecting electrical equipment and systems to the earth, providing a path for fault current to flow safely back to the source. This helps to prevent electrical shock hazards and reduce the risk of fire. The NEC specifies detailed requirements for grounding, including the size and type of grounding conductors, the methods for connecting grounding electrodes, and the bonding of metal enclosures and equipment. Another critical consideration is overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of electricity when a fault or overload occurs. This prevents damage to electrical equipment and reduces the risk of fire. The NEC provides guidelines for selecting the appropriate overcurrent protection devices based on the ampacity of the conductors and the characteristics of the equipment being protected. Wiring methods are also carefully regulated by the NEC. The NEC specifies the types of wiring methods that are permitted for various applications, including the use of conduit, cable, and other wiring systems. The selection of the appropriate wiring method depends on factors such as the environment, the voltage, and the type of occupancy. The NEC also provides guidelines for the installation of wiring, including the spacing of conductors, the support of cables, and the protection of wiring from physical damage. Electrical boxes and enclosures are essential components of electrical systems. They provide a safe and secure enclosure for electrical connections and devices. The NEC specifies the types of electrical boxes and enclosures that are permitted for various applications, as well as the requirements for their installation. Electrical boxes and enclosures must be properly grounded and bonded to ensure electrical safety. Wiring and cable ampacity refers to the current carrying capacity of electrical conductors. The NEC provides tables that specify the ampacity of conductors based on their size, type, and insulation. It is crucial to select conductors with adequate ampacity to prevent overheating and potential fire hazards. Voltage drop is another important factor to consider in electrical installations. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC provides guidelines for calculating voltage drop and recommends measures to minimize it, such as using larger conductors or shortening the length of the circuit. Arc fault circuit interrupters of size are devices designed to protect against electrical fires caused by arc faults. Arc faults are dangerous electrical conditions that can occur when damaged or deteriorated wiring creates an unintended electrical discharge. Size detect arc faults and quickly interrupt the flow of electricity, preventing fires from starting. Ground fault circuit interrupters, GFCIs, are devices designed to protect against electrical shock hazards. GFCIs detect ground faults, which occur when electricity flows through an unintended path to ground, such as through a person's body. GFCIs quickly interrupt the flow of electricity, preventing electrical shock. Electrical safety is of utmost importance in any electrical installation. It's essential to follow all applicable codes and regulations, use appropriate safety equipment, and take precautions to prevent electrical hazards. Working with electricity can be dangerous, and it's always best to consult with a qualified electrician if you have any questions or concerns. Consider a scenario where a homeowner is renovating their kitchen and decides to install new lighting fixtures and outlets without obtaining the necessary permits. They might not be aware of the electrical code requirements or the potential safety hazards involved. Without proper grounding, the risk of electrical shock is significantly increased. If a fault occurs in the wiring, such as a short circuit, the electricity could flow through a person's body if they come into contact with a metal appliance or fixture. This could result in serious injury or even death. Without overcurrent protection, such as circuit breakers or fuses, the wiring could overheat and cause a fire. If the wiring is not properly sized for the load, it could become overloaded and start to melt or burn. This could ignite nearby combustible materials, such as wood framing or insulation, and quickly spread throughout the house. Without proper wiring methods, the wiring could be exposed to physical damage. If the wiring is not protected by conduit or cable, it could be easily damaged by nails, screws, or other objects. This could lead to short circuits, ground faults, and other electrical hazards. Without proper electrical boxes and enclosures, the electrical connections could be exposed to moisture, dust, and other contaminants. This could lead to corrosion, short circuits, and other electrical problems. With out of size and GFCIs, the risk of electrical fires and electrical shock is significantly increased. A size can prevent fires caused by arc faults, while GFCIs can prevent electrical shock caused by ground faults. In addition to the safety hazards, unpermitted electrical work can also have legal and financial consequences. If the homeowner is caught performing unpermitted work, they could be fined or ordered to remove the work. They may also have difficulty selling their home in the future, as potential buyers may be wary of unpermitted work. Furthermore, their insurance coverage may be voided if any accidents or damages occur as a result of the unpermitted work. To avoid these problems, it's always best to obtain the necessary permits and hire a qualified electrician to perform any electrical work. A qualified electrician will be familiar with the electrical code requirements and will ensure that the work is done safely and correctly. In the context of the initial question, documenting your work, informing your friend, offering assistance, clarifying your role, confronting the homeowner, offering alternatives, setting boundaries, documenting the conversation, protecting your reputation, reporting the incident, ethical concerns, legal liability, insurance coverage, and professional reputation are all critical considerations to protect yourself from potential liability and ensure the safety of the electrical system. It's always best to err on the side of caution and seek professional advice when dealing with electrical work. In any electrical project, you must prioritize safety. Always turn off the power before working on any electrical circuit, and use appropriate safety equipment such as insulated tools and rubber gloves. Never work on electrical equipment when you are wet or standing in water. If you are not comfortable working with electricity, it's always best to hire a qualified electrician. Remember that electrical codes and regulations are constantly evolving, so it's important to stay up to date on the latest requirement. You can consult with your local building department or a qualified electrician to ensure that your electrical work complies with all applicable codes. A key component often overlooked involves calculating the load on any electrical circuit. The NEC specifies how to calculate the load for various types of circuits, including lighting, appliance, and receptacle circuits. The load calculation determines the required ampacity of the conductors and the size of the overcurrent protection devices. Another vital aspect is understanding the different types of electrical wiring. The NEC recognizes several types of electrical wiring, including non-metallic sheath cable, NM cable, armored cable, AC cable, and conduit. Each type of wiring has its own advantages and disadvantages, and the selection of the appropriate wiring method depends on the application. Grounding electrode systems are also critical for electrical safety. The NEC specifies the types of grounding electrodes that are permitted, such as ground rods, ground plates, and metal water pipes. The grounding electrode system provides a path for fault current to flow safely back to the source, preventing electrical shock hazards. Bonding is the process of connecting metal parts of an electrical system together to create a continuous electrical path. Bonding helps to reduce the risk of electrical shock by ensuring that all metal parts are at the same potential. The NEC specifies the requirements for bonding various metal parts of an electrical system, such as metal conduits, metal enclosures, and metal water pipes. Surge protection is also important for protecting sensitive electronic equipment from damage caused by voltage surges. Voltage surges can be caused by lightning strikes, power outages, or other electrical disturbances. Surge protective devices, SPDs, are designed to divert voltage surges away from sensitive equipment, protecting it from damage. Electrical inspections are crucial for ensuring that electrical work complies with the NEC and local building codes. Electrical inspections are typically performed by qualified electrical inspectors who are employed by the local building department. The inspector will review the electrical work to ensure that it is safe and complies with all applicable codes and regulations. When performing electrical work, it's important to use only approved electrical equipment. Approved electrical equipment has been tested and certified by a recognized testing laboratory, such as Underwriters Laboratories. All approved electrical equipment is designed to meet specific safety standards and is less likely to cause electrical hazards. Proper labeling of electrical equipment is also important for safety. All electrical equipment should be clearly labeled with its voltage, amperage, and other important information. This information helps to ensure that the equipment is used correctly and safely. Maintaining accurate electrical records is essential for future maintenance and troubleshooting. Keep records of all electrical work that is performed, including the date, the type of work, and the materials used. These records can be helpful for identifying and resolving electrical problems in the future. Regularly inspect your electrical system for any signs of damage or deterioration. Look for frayed wiring, loose connections, and damaged electrical equipment. If you notice any problems, have them repaired by a qualified electrician as soon as possible. Educate yourself and your family about electrical safety. Learn about the dangers of electricity and how to prevent electrical accidents. Teach children to stay away from electrical equipment and to never insert objects into electrical outlets. In summary, protecting yourself from the consequences of unpermitted electrical work requires a comprehensive understanding of electrical codes, safety practices, and potential liabilities. By following the guidelines outlined above, you can minimize your risk and ensure the safety of your electrical system. Remember to always prioritize safety and consult with a qualified electrician if you have any questions or concerns.